All right, welcome everyone. Day 2, Atlas. We have a great talks today. Session 1 is going to be Enterprise AI, and our first speaker is Sunita Verma with Ironclad. Welcome, Sunita.
Thank you very much. Yeah. Good morning, everyone. I hope you had a wonderful time yesterday, enjoyed the sessions. My name is Sunita Verma. I am CTO at Ironclad. Prior to coming at Ironclad, I spent almost 18 years at Google building and deploying AI technology at scale for various use cases. So I'm going to talk about, I'm going to make a claim, and I'm going to use the next 10 to 15 minutes validating or supporting that claim with some of the data that we have seen. And my claim is that, and actually the video that was playing beforehand sort of set it up properly, very appropriately for me. The adoption of AI in enterprises is not stalling because the technology is not working or is not there. It's stalling because of other reasons. And one of the other reasons tends to be processes, culture, and so on. And the question I think we all want to ask is, why should you care? Why do you want to care about whether the technology gets deployed in an enterprise or not? And my claim to that is all the good work, all the great work that we heard about yesterday, that we're going to hear about today, needs to deliver value. Otherwise, it's all for a naught. So who are the eventual users of this technology? It's going to be all the people who live in thousands and thousands of companies that exist around us. So I want to start with a story. 9 months ago, which is approximately like a month or two after I had joined Ironclad, we were having a discussion about features, and I deliberately ran an experiment there. I asked 2 different engineers for an estimate of what it'll take to build that feature. And guess what I found? I found such diverging amount of time in estimates that it gave me a pause. I'm like, what's going on here? And then when I dug into it, one of the things I realized, it's actually less about the seniority of the engineer or familiarity of the engineer with the code base. The difference was one of the engineers was AI pilled and understood how to use the technology and work with the technology and steer the technology and so on. And the other was using AI technology mainly as a chatbot, but felt that they already had mastered the technology. And so I had a choice to make at that point. I knew that the rate at which the technology is advancing, this gap is going to get compounded between people. And I could actually accept to have a 2-speed engineering organization, or I could do something about it. So one of the things I stepped back and thought about is, why is it that people feel that they have mastered the technology when they actually haven't? And at least my assertion is, in the previous technologies, whether it's mobile, whether it's cloud, when you had an error, the error was obvious to you. The technology sort of pushed back, and you knew you had to fix the error. You knew you had to learn what's going on or what's going wrong before you could make progress. But with AI, because the interface is natural language, just by talking to it, you sort of feel you already know what you're doing, without realizing that the outputs need to be validated, the outcome needs to be validated. So it actually it's a very different mental model that you have to use with this technology. And yes, many of you sitting in the audience may say, oh, I already knew that, but there is a huge workforce out there that is not in the same mindset as a lot of people sitting here. So if you want the technology to be adopted by that set of people, it's important that we do something about it. So one of the things I also learned from a lot of other companies, talking to a lot of other companies is, and these are big Fortune 500, sometimes Fortune 100 companies, most of the companies say, oh, we'll enable our engineers. And I think that's a myopic view to take, because you enable one function, but then you create bottlenecks in other part of your organization. So one of the very deliberate things we did at Ironclad right from the beginning is, We will enable everyone at the same time. Yes, some people were already pretty AI pilled and they felt that they didn't need this, but we were very clear that we want engineering, product, and design to work together to get enabled together. So one of the goals we set for ourselves, I set for the team, is we want to make sure we are a company where building with AI and building AI is not a bespoke act for certain people. Everybody can actually build it. Everybody can build it with the technology. So 3 principles we basically said. There are just going to be a haloed set of people on this side that are doing AI, and then they pull everybody along with them. That hard parts of making sure the outcome validation, the evals, the eval harnesses, everything is going to be through tooling so that everyone gets the benefit of it at the same time. And then it's not going to be more like, hey, only certain top people get to use AI and nobody else. Everybody has to use AI and everybody will use AI. So we basically set it with these principles. And what I did was I leveraged one of the things we had coming up. So I was just 3 months into the company at that time. We had a hackathon coming up in December 2025. So I'm talking 8 months back, which is an eternity in AI. December 2025, we had a hackathon coming up, and I wanted to make sure that the team actually comes prepared with AI in this hackathon, and we basically see AI build-related outcomes from the hackathon. So I created a 20-day program prior to the hackathon that we ran prior to the hackathon to basically do the skill building across the organization. And we are at a much different place as a company now, but this is basically 8 months back. Day one, because I built technology, I'm very familiar with the technology, I actually took classes for the whole team, and I think we allowed anybody across the company to be able to join those classes. So I took classes on basically LLM fundamentals, how LLM works under the hood, how to think about context, in-context learning, prompt optimization, tuning, evaluations, and so on. And then for the next 20 days, for the rest of the 2 to 20 days, one engineer every day will basically come and talk about how they built what they built with the technology, how they built with the technology, what problems they ran into, and what learnings they took away from it. And we kept the momentum going through Slack channels, through interactions, through sort of impromptu get-togethers that engineers wanted to do among themselves. And so we ran the whole program in 20 days. And come hackathon, we actually got huge amount of participation. We got a lot of people building capabilities, building new things that I didn't think that the team could build, but they surprised me significantly on a positive side. So fluency-wise, we were there as a company at that point. And one of the things I was expecting to see out of it, and this is now we are talking about January 2026, again, still 7 to 8 months away from where we are today. So I'm just telling a story. This is not the state of the company where we are today. January 2026, the sort of the feature development part didn't sort of take off as at the same rate as I had thought. And again, I'm like, okay, what happened? I thought we had already upskilled everybody. We should be seeing all this building happening in the product. In experimentation, we were already there, but in the product, we should be seeing all this building happening. So what's going wrong? And I realized it is actually Amdahl's law. And what Amdahl's law says is you update one part of the process, but now the parts of the process that you didn't touch actually become the bottleneck. And one of the things I realized is, yes, we were building, every function was building AI and building with AI, but we had not shifted the process at all. And we were still following a waterfall model of development where product will do its research, they'll hand it off to UX, and then it'll come to the engineer, and engineer will basically get done really quickly, and then most of the time they'll be just waiting for answers from the product team. I'm like, oh, okay, so this is actually where we need to fix we need to actually change our approach. So we basically tweaked the process. I already talked about education being the infrastructure, and part of that education being the infrastructure is building a shared lexicon, building shared tooling, building harnesses, and making sure that there are common systems for context management, RAG, memory across the board. So we are basically brought all the organizational memory into a single system. But I think it's the process part of the shifting that actually was very interesting. So what we do now is when trying to build something, the relevant people will come together early on. They'll basically get together, they'll discuss the problem, they'll debate the problem, they'll come up with a solution, they'll iterate on the solution, and they will memorialize the solution as either a markdown or a Notion page. And I don't know if any of you attended Professor Ian Stoica's talk yesterday. One of the things he was talking about is why the outcomes from AI are not what people expected it to be. Part of it is under specification of the requirements. And having everybody come together in the early stage of the process allows us to flesh out those requirements right in the beginning before handing off that fleshed out work to an agent to execute, to an AI agent to execute. I'm not saying we are perfect there, but I think we have seen the benefit of specifying, like clearly specifying the constraints and the boundaries and the solution space of the problem before giving it to an agent to execute, and we are seeing really good outcome, and I'll show you some data around that as well. The last but not the least thing is basically we have created tools and guardrails that ensure, so obviously there are code review agents, but there are just a lot of skills that we have built to ensure that the quality of the outcome that is produced by these agents, especially on the coding side, meets the requirements, the standards that we have in our company, and so that nobody has to wonder whether their agent is doing the right thing or not. So where are we as a company? So what I told you was up to January 2026, AI space moves really fast, and we move really fast. We moved really fast to keep pace with it, or to outpace it sometimes, actually. So we have created an agent framework, and this is sort of a cartoon diagram. I omitted some of the deep technical details from here. We have created an agent framework, which basically enables anyone to create an agent really quickly. And it's based on Agent SDK from OpenAI and AI SDK from Vercel, connected to all the frontier models. We have also started tuning actually our own models, so some of those models are also getting hooked up behind these agents. And we built all the other infrastructure around it for continuous context optimization, memory management, continuous evals, prompting, and so on. So this is sort of the framework that the whole company uses now to create agents. We've also basically automated evals in large parts of our system, and evals tend to be one of those under-specified things or under-invested things that people use. So we do have LLM judges that are actually evaluating the output that is being produced by a lot of these agents. And then they give it to an evaluation agent, which then compares it against a rubric. And till it basically decides that, yes, the eval is actually coming very close to the rubric, it'll keep running those continuous evals without involving any of our engineers in the process. So once something has been built, reviewed, and checked in, it basically goes through this evaluation process automatically. We've also built our own code generation harness. We evaluated everything actually out there. We basically evaluated Codex harness, we evaluated Claude's harness, and so what we did was none of them were coming close to what we wanted to build. So we basically took them as benchmarks, some of the open source ones as sort of the substrate, and we built our own code generation harness on top of it. We are using Temporal, and Temporal was here yesterday, so shout out. So what people now do, and by the way, our product managers are also coding now, because it's just so easy to do the right thing. So anybody can actually interface with this harness. They can actually give it a job to do, whether it is a UI that you want built, whether it's a backend part of the service that you want built, whether it is any other part of the code you want written. You can give it to the harness. The harness actually spins up a VM. It basically sets up the whole environment, almost equivalent to a production environment in that VM, generates the code in that VM, tests the code in that VM, and produces a review-ready PR that can then get reviewed by either humans or a review agent. This is sort of what the web interface for our harness looks like. I've deliberately sort of made the colors weaker because there are some things that I didn't want that are more proprietary to us. So basically, this is a harness that people use. It's in dog food right now, and we are getting really, really good results from it. We've also delivered a lot of value in the product. By the way, as I said, we are a legal tech, commercial legal product. Almost all the companies in Silicon Valley are customers, including the Frontier Labs. And so there are a lot of products that are agents that live in our product today. And those agents are running real contracts, which are billions of dollars of value that is running through them at this point. 9 months later, this is where we are. It's a very different place for me as well as a company. These are more engineering statistics. And by the way, the drops you see at the end of the curve is incomplete data. It's not that, we've suddenly become, we are suddenly back to square one kind of thing. So our execution velocity is just very, very different than what I saw a year ago. Just one last thing I want to leave you with. It's not that this is something that's proprietary to us. Actually, one of our customers reached out to us. It's a Fortune 100 company that reached out to us and wanted to run the same program, us to run the same program for them. We didn't design the program to run it for other people, but it's a customer, enterprise customer, and a big customer, so we just wanted to make sure that we are able to support them as well. We ran the program for the customer, and the outcomes were very, very similar. The customers are also seeing acceleration in the work on their side. And again, I know time is up, just 1 second. I think if any of you attended Andrew Ng's fireside chat yesterday, one of the things he was talking about, he's worried about lack of education or lack of investment in education by a lot of people building AI, because that is going to become one of the barriers to adoption. And so we are sort of seeing, I'm giving you a data point from our experience in support of that claim. And we are saying something very similar, that education is an important component of getting AI deployed in enterprises. Just a little bit about Ironclad very quickly. As I said, we are almost all Silicon Valley companies are customers for us, including all the Frontier Labs. The ones we have logoized, I'm putting the names down at the bottom, have thousands of customers and so on. That's it from my side. I'm going to be around in networking sessions or breaks if you want to chat with me, and this is my LinkedIn in case you want to follow. Thank you very much for your attention.
All right. Thank you, Sunita. Next up, we have Ori Goshen with AI21.
My name is Ori Goshen. I'm the co-founder and CEO of AI21. AI21 is an AI lab based in Tel Aviv. Super excited to be here and tell you about our work around self-optimizing agents. And so today we'll speak about kind of these self-evolving AI systems, why it's needed, why it's hard, and why now. And I mean, the time is now. I mean, we all see the challenges in the industry, and we'll speak about it. And of course, I can say personally for myself, my wife is asking from me this feature all the time, and I'm probably still in the early beta version. So in the past few months, we've seen many of these AI systems actually shift from experimentation to production. We're still very early in this journey of AI adoption, but we're seeing systems that are now being actually deployed at scale, and this introduces a new set of challenges. And the most obvious one is to operate economically at the frontier. And what we're hearing from customers again and again is that we have this agent, we're pretty satisfied of how it functions and the overall performance, but we know that if we would want to apply it for every PR or for every call or for every booking or for every transaction, it will be prohibitively expensive. So, and this has been the talk in the last couple of months. Token maxing is basically over, Now everybody is speaking about token efficiency, and that becomes kind of the focus of the industry. And the question is really, how do we get the best possible performance per token investment, or how do we basically get the best real customer outcome per dollar investment? That's the real question, and I think we as an industry become smarter about it. This is what we see a lot of customers aspiring to achieve, basically, where you want to make the acceleration of the AI usage. You want to see the outcomes of that AI usage. So the kind of, I don't know if you can see it very clearly, but the black line is essentially an indication of the usage of a certain company in terms of tokens. And the bars represent the cost, and the cost broken down per model. So you can see at one stage, this company, in this case, Coinbase, we're able to get more control over the cost and have that correlated lines basically disjoint. So that's where companies are looking to get themselves. And here's a typical flow of an optimization process. So you have an agent. You start with several configurations, and we'll speak about the configuration space, which is pretty vast. And then after experimentation, you kind of discover the Pareto frontier, the set of operating points that you would want to select a point from. And then you select an agent candidate, and basically you start evolving the system from there. And in many cases, we see that you have a target operating zone in terms of cost and quality, and you're trying to get your system, you're trying to get your agent performing in that level. That's easier said than done. If you look at this is like a very kind of a caricature of the configuration space. You have a lot of levers to play with. Obviously you have the model itself and the model weights that can be changed. You have model selections. We're now in a world where there's so many different models that are presenting very different capabilities and performance characteristics. But then you have the harness, which also plays a very important role. And the harness includes the tool specifications, the prompts, the skills, actually the code, the scaffold that you build around it. There's so many moving parts, and that represents a challenge. So let's look at a concrete example. One of them is around a benchmark called BrowseComp. BrowseComp is basically a deep research benchmark, which is verifiable because the information, the answer, it's not an open-ended benchmark. The answer is included inside the given corpora. The first thing you do is, again, map the candidates, as I showed earlier. So you would try, in this case, different models with different configurations, in this case, in different retrieval configurations. You have like a dense retrieval and a sparse retrieval and another strategy retrieval of a late interaction. And what you see here, again, in Berkeley on this benchmark, is basically the GPT-5 family with the late interaction retrieval and the minimax. They basically represent the Pareto frontier. You would want to select between these two options. That's the very basic, and I think most of the teams are doing these kinds of mapping before they go to production. But then there's another dimension. There's scaling. You can apply different execution strategy. For example, vertical scaling, like the amount of thinking tokens or the amount of iterations you give the loop, or the different types of fix repair loops that you can apply. Or you have horizontal scaling when you basically try to generate multiple candidates and then select or merge results from those set of candidates. If you look at, and this is well known for being best of n, right? You basically use the same model to generate multiple candidates. You run them in parallel, and then you compare and you pick the best one. And what you see here in the same benchmark, you're actually starting to discover new types of result. The yellow line here is representing the Minimax, which was the cheaper but also lower in terms of quality. And now, if you look at the chart, you see that if you horizontally scale, you generate multiple candidates and pick the best one, you can actually, using the same model, get to the same level of quality of the top quality candidate in the earlier chart. But what you also see here is that scaling each of these models, you get better and better results. For example, the GPT-5 also increased quality in comparison to cost. So basically, you discover more options, right, to run your agents with this. Another strategy is basically operating on an ensemble, a portfolio of models. So not just generating candidates from the same model, but generating candidates from different models. This could be with adjusted prompts and tool definitions, et cetera. And then, again, you can take all of these outputs and combine them into the most optimal result. And again, I think this is really in line with the discourse we're seeing today, moving from token maxing to model maxing. How are we able to harness more and more goodness from different types of models? And what we actually see, again, under this benchmark, although it's applicable pretty broadly, is that different types of models, they cover different areas of the space. And so if you are pretty diligent about measuring the covariance and how each model is contributing, you can gain a lot of benefits. So the sum of using all models is greater than using them separately. And if you apply these techniques smartly, you can gain a lot of outcomes. So for example, basically applying this portfolio strategy, you essentially discover a new Pareto frontier where you have better cost performance, mixing these different models in different proportions. And this is something that can be learned per task. It doesn't have to be manually discovered. You actually can learn these different combinations. And what you see here, for example, is that you're able, with that portfolio construction, you are able to get to about 50% less cost for about the same quality if you use the previous state-of-the-art setting. So really the same thing applied if you compared not just accuracy with cost, but also accuracy to latency. It's the same basic principle. So now you have this, you have a lot of options, but now there's another dimension of execution strategies, right? You can chain those different call to models differently. You can use different escalation strategies. You can prioritize calling one models to another. And you can set some different stopping threshold, which also impact the performance. So this is another dimension, and here we'll look at another, just for the sake of diversity, we'll look at another benchmark, the 3Rebench benchmark. And here's a work where we actually see that changing the execution strategy also has an impact on different trade-offs. In this case, cost and latency trade-offs. So The simple best of n means you run all the candidates, you let the last one get the outputs, and then you pick the best one. A more efficient strategy is to do it like a cascading order. You start with the weakest model, and you go from there. And when you reach a stopping point where you're satisfied with you're confident enough about the results, you stop. So you're making gains there. But you can also do it in parallel and have that same early stopping strategy applied. And in that case, you're not saving on cost, but you're more saving on latency. You're more optimizing for speed rather than cost. And then basically what you show here is that you can play with that trade-off, the same level of quality. You can apply different types of execution strategies and gain different trade-offs between cost and latency. So if you care about speed, you can use one setting. If you care about cost more, you can use another one. One final example on the execution strategy is very much like human, and if we take the legal example, right, when you come a legal task, we typically have many junior interns doing the busy work, and then it rolls up to a more like an associate that synthesizes some thesis around it, and then finally we have the partner who's concluding and making the final decision. So same thing can be applied in coding. In this case, we show that if you have a weaker model, just generate many rollouts, then a stronger model, enrich those rollouts with more relevant information. And then like a super strong model, like a Fable level model, generate the final patch and making the final decision, you actually get better quality and with much cheaper, like 3x cheaper than just using a frontier model. So all the gist here is that all of these strategies can be learned. The search space is huge, right? So it's not a simple problem, and doing it manually, you'll probably miss a lot of optimization opportunities. So we want to find an automated way to do it, and one kind of challenge of doing it manually is, what happens when a new model comes in, or when a pricing change, or the environment change, the traffic also, like the task distribution also changes over time. So you need to address all of these, right? That's why basically manually searching this space is not something practical. So what we do at AI, I know I'm way over time, is we offer a suite for enterprises, like a toolkit that helps them, given an existing agent, no matter what framework or runtime or what models this agent is operating with. We basically help companies optimize their agents in production, aligning with their production traffic, so it can continuously evolve and get to the best price performance and according to the customer's preferences. So kind of to conclude about why we need an automated way to optimize these agents, we want to make them efficient. We want to make this an efficient process. We want to make it observable so people will be able to see the different trade-offs and select from them. And we want this to be future-proof, so when a new model comes in or when the distribution shifts, it's very easy to adjust our agents and make them performant in production. You're more than welcome to check our research in this area. In our blog posts, we post every few weeks about new discovery around agent optimization. And I thank you very much for your time. Thank you.
All right, thank you, Ori. Next up, we have Renee Paeta with Microsoft. Welcome, Renee.
Good morning, everybody. This session will be slightly different because we talked a lot about what we're building, how we're improving all those technologies. And I'm focused more about how these technologies are adopted in the organizations, how they are actually used. With Vibe Engineering, we see a lot of things being created, but struggling to get the adequate usage and live through in the organizations. I'm basically a chief architect at Microsoft, advising the CTOs and CIOs of Fortune 500 organizations. I focus on their AI transformations and both how to build with AI, but also how to build agents which are worth to purchase and create the new business models for them. And also at the same time, I running as a technical lead our own sales or customer success account transformation, where we have around 700 people, and we're building our own agentic systems to help us to run accounts better and uplift the quality of how we run our own business. And I would like to start maybe with a concept called enterprise unicorn. Right? We heard about like one-person unicorns to be, and this is a bit looking at what it takes, maybe how that could look like in the larger organization, which has over 10,000 people, and what it will be as a shape and form in there. And I believe a lot of that going towards, rather than talking about the headcount, is going about how we're going to operate in, let's say, a few years. And I call it either a mission control or a command center. Basically having a human, an agent, a shared state where we have a pre-built signals based on which we can act in the organizations even before we ask questions. The chats are more things of dealing with exceptions and trying to capture those as a new signals which we have to make the decisions in the organizations. And it really, like I would say, a simple test of this will be that how many meetings we will need to have to sync internally as an organizations. In ideal state, we won't need those meetings because everybody is on the same page as we capture that intelligence within the organization. And as usual, it all starts with the waves, right? We started with chats, with assistants. Now we kind of have the micromanagement of agents where we run the task. They run for a while, but then they still need our steering, or we don't have developed the trust into them. And we want to move to the delegation and remote execution, what we see with promise of the open claw, automated agents running parts of our businesses. And I still would say that majority or a lot of the enterprises, large organizations, are in that micromanage state because of a couple of things that we just have the system access to the systems which needs to be connected to really done the work. For example, I'm a salesperson. I need to connect to like 3 to 4 different systems, and I need to have access to those, combine that information, right, to bring and build that one mission control system. But that's not enough, right? I need an intelligence how we as an organizations are using that, and that usually the vendors cannot build. That needs to be built by the organization internally, and therefore there are still, I would say, in the micromanagement state because we have those connectors, but that company intelligence still needs to be developed in the organization. So I would say like moving to the delegation piece will really require that wider system access to have all that information to bring it in one place, plus the tacit knowledge of the organization to develop the trust on top of those workflows. And because of how we see how the organization, or let's say the technology evolves, we see new models every 3 months, we see new frameworks, harnesses to being positioned. The CIOs and CTOs have really tough questions there, like how I find the clear direction, how I bet on what technologies to evolve and upskill my organization to survive such waves of different technologies. Imagine like if you have 10 people in your organization, it's pretty much a daily business to also learn and adjust. However, if you have an organization of 10,000 people, it requires a lot of coordination efforts, communication, enablement, strategy. And if there is no clear direction to that, usually what happens is either people wait or they start building on their own, which then creates one part is just stale organization, the other one is basically creating a shadow IT with web engineering that's even booming, and then it's very difficult to create a governance, right? Ideally, the companies want to operate like a small city with clear laws, but also freedom to experiment within those boundaries. And that's also where the efforts then going really in terms of standardization, right? We need to have a standardization in terms of the governance, in terms of the policies. We do have to enable those laws to be around, and then allow those on the edge actually to build and innovate, because there is that tacit knowledge captured in the organization. We don't know centrally, let's say in the organization, what's happening, what are the nuances, how the organization operates, and we need to have both of those. So a lot of questions come to what I buy and what I build. Where is the mode and where is a commodity in that space? And I would say what we a lot see, like the models, the agent harness, the connectors, that's all a commodity which you ideally focus on buying. But then the mode for the organization is their company intelligence. How I capture that intelligence of my organization. And an example from our side is, I'm running a report. We have a reporting system which has around 400 reports, right? I have a connector to it, but that connector is just giving me access to go and query those reports. However, what I need to do is really to understand how my expert teams are using those reports, when they use what. And that's basically what we also do. Is one layer is just the connector itself, the other one is going and crawling those systems, creating kind of navigation, like mental model, capturing how my employees are going and retrieving that information, right? Because that allows me to actually have agents which I can trust, have agents which are making less mistakes. They are not kind of these junior intern employees. They are experts, and they're even better than I am in doing that job. And that also then, with the latency and the cost, actually reducing, because they make less mistakes on achieving that specific task. And that's basically like where we saying also this company intelligence is something durable. It's where you want to capture those nuances, right? You can have let's say, global sales book that can be shared globally, but then the nuances, how we handle, let's say, our accounts in Germany, or how the others handle accounts, let's say, in Japan, it's very different nuances, which you can't globalize and generalize, and needs to be captured on that edge level. And once you know, like, what you want to build and what you need to, let's say, buy, it also comes with the kind of the operating model, meaning that you have that central spine where you're building, let's say, the key connectors to the systems, right? You don't want to have your field to go and do the authentication and authorizations, integrations to the key critical systems. You want to have that done centrally. So you provide that access to the data for the teams, but then also on the other side, you for the edge, on the edge for your employees allowed to, let's say, build around it. They focus more on how to capture the knowledge of that day-to-day task and operations. Because if we have just everything centrally, we create well-governed systems, but which are missing work because they are not doing exactly what we on the edge expect. And on the other side, if we just let everybody do the innovations on the field side, we're creating and booming the shadow IT, which is very difficult to govern. And with that, I would say, coming back again to, let's say, that one-person unicorn, it won't be, let's say, one person doing the work. It will be everybody having, kind of being a CEO in a boardroom, having their own set of agents and workbenches which allow them to take the decisions on a daily basis. Imagine, I think our work will shift to the point that we have a queue of, let's say, your colleagues behind you asking questions on different topics, and you make the decisions. So it will come also with a new type of mental loads on us. We are not used to the decision-making on constant basis. We are very difficult with content switching, right? So these things will be creating challenges for us mentally, as well how to adjust at the work, and also the trust will be very important because if we can't trust our delegates who do the work for us, we won't be able to make those decisions. And those two things will be shifting, and at least what I see across the enterprises. So if I should leave with one, it would be buy the models, buy the commodity, and build that intelligence layer in your organizations. Thank you.
All right. Thank you, Renee. Next up, we have Vincent Sun Chen with Snorkel AI.
Thank you so much for Berkeley and the RDI group for putting this together. I'm Vincent. I'm one of the founding team members and a research leader at Snorkel. We've spent years building data sets with frontier labs and enterprises and deploying these agents in real-world scenarios. And in this talk, I wanted to talk about what makes benchmarks and evaluation methods really effective and how to actually make them last. How do you build really robust measurement sticks that are adopted by the field and actually influence the way the field is going? So really quickly about us, we've been working on data for a very long time. We have a number of academic groups, from Chris Ray's group at Stanford to Alex and Fred's groups at Wisconsin and Washington. And our key focus over the last decade plus has really been on data-centric methods for effective frontier AI. And so we're really privileged these days to be able to work with some of the best academic groups out there in accelerating and partnering on some of these open benchmarks. We're very humbled to work with some of these awesome benchmarks on the board. Very own kind of Don Song's Agents Last Exam. We were very happy to help as a data and research partner, helping with some of the quality control mechanisms. We've also partnered on a number of recent benchmarks, including Continual Learning Bench, also from Berkeley, out of the Sky Lab, OS World 2.0, and very recently the last few versions of Terminal Bench, which actually just shipped in the last few weeks. In this talk, I'm going to mention some of the learnings we've had on our work on these benchmarks and maybe put out a little bit of a call for the types of problems we think are going to be really important to solve in the space here. So the key problem here is that our ability to measure AI has really been outpaced by our ability to develop it. We're seeing that benchmarks in general are becoming really, really important, but they're also increasingly difficult to build. There are new challenges when it comes to, take coding, right? Human eval launched several years ago is at 95%, and most recently the Harding programming benchmarks are at 3%. And as you climb the scale of complexity, you find that it's increasingly challenging to actually verify and evaluate a number of these tasks at the frontier. Benchmarks have also never mattered more. They are important for steering research agendas, model releases, and billions in compute are actually pushed towards hill climbing and addressing these benchmark gaps. We think that building benchmarks is a real research focus area that is non-trivial. Benchmarking is a real problem. We think that models tuned to the test require a lot more thoughtful design and community contribution to ensure that we're providing really effective standards and measuring sticks for the field. What I'll call bench slop, the idea that you can really quickly vibe code a benchmark and get a fancy Twitter post out, is increasingly a really large problem where the individual task quality is lacking and a lot of effort needs to be put into designing extremely high quality tasks. And lastly, as model capabilities improve, they also improve at reward hacking and tricking and deceiving the benchmark builders, where it becomes a bit of a cat and mouse game in improving our methodology for building effective benchmarks. So this is really hard, and we want to talk a bit about some of our learnings for addressing these challenges and some examples that we've pursued. The other angle I wanted to talk through here was the fact that with agentic AI, the shape of data is becoming increasingly non-trivial. Right, we moved from a regime of much more simple prompt response pairs or simple thumbs up, thumbs down type of feedback mechanisms in terms of data labeling and data development to a much more complex stack of data sets and RL environments. Right now we're seeing entire environments or worlds built up from rubrics to verifiers to tools with complex environments that mimic our day-to-day settings. And I'll note that this adds to the complexity in measuring these types of data sets. So as the surface area keeps expanding and certain tasks continue saturating, you might think, oh, we're done with certain fields, or we're done measuring coding, for instance. And I challenge that as you push the frontier along a number of axes of complexity here, right? One of our views is that sequence length, or kind of the length of autonomy on the y-axis, is a really important axis. And on the x-axis, we have kind of input, output, and environment complexity. Hey, what are the types of tasks or outputs that you're solving? It becomes increasingly more important to drive the next wave of benchmarks. And so, again, this is kind of what I alluded to earlier. There's a long tail and a very important space of problems to measure in the coding space. And despite coding becoming so impressive in the last year or 2 years, we think there's a lot of work to do in the benchmarking space as well. Okay, so I want to talk about one of the benchmarks we recently pushed out and share a little bit of our philosophy interweaved in how we built this and what the principles are for building effective benchmarks. We launched last month something called Senior SWE-Bench. We were very fortunate to work with the original SWE-Bench team over at Princeton, and the key thesis for this benchmark was the fact that our agents are moving far beyond the level of junior engineering capabilities, but we don't really have a good way to evaluate them at the senior level. What do you think of when you think of a senior engineer? These are folks who can capture underspecified requirements. They can take an ambiguous problem and run with it. They have some notion of taste. We tried to address all of these types of issues in this next evolution of the SWE-Bench series. So a few principles first, right? We think that really effective benchmarks in general are one, kind of important research agendas for the space, and two, really well specified kind of measurement tools in general. And so, Senior SWE-Bench, as I mentioned, was the benchmark we're going to talk through here. So number one, the research agenda, right? We think that a lot of the greatest benchmarks have a really strong thesis on the frontier. They are making a bet on where the field is going. I think the Terminal Bench team did a wonderful job doing this, right? Several years ago, they made a bet to say, hey, we think that the future of agents is going to happen at the interface, the text-based interface that agents and LLMs are already doing a great job at. I think that was very much a correct bet. And we're seeing now that this is one of the most widely adopted benchmarks on, I think, literally every frontier model card. We think the best benchmarks also set a roadmap for the field. Again, SWE-Bench, released several years ago, has now seen a big series that we were very happy to contribute to the lineage of. And they're really great research tools for setting the stage for our fellow colleagues to build on top of. And really critically, we think the best benchmarks consider researcher UX. They really consider how do we make it easy for other folks to build on top of this? How do we build the right primitive so that other members of the community can actually contribute? So how does this apply to Senior SWE-Bench? What is our core thesis here? A few different points I wanted to make. Number one, we capture naturally underspecified instructions. So when you talk to a senior or principal engineer on Slack, you're not specifying a full EDD. You're not specifying, line-by-line instructions for what to do, what not to do. They're Slack messages. They're, hey, here's a dump of error logs. Go investigate this. Or, here's a few bullets on what I think the user stories are going to look like. Go figure this out. So that was one of the key axes we tried to capture, working with our expert network, but also a number of methods we built internally. Two, we captured a much longer horizon of tasks. So these are tasks that challenge engineering skills. They capture multi-service changes. They're not just a single patch in a very local way. They intentionally target really complex, longer horizon tasks. And three, we wanted to build this benchmark as something that could scale in terms of something that other researchers could build on top of. It wasn't a one-time effort. It was something that, hey, continually sources from the latest and greatest open source repos and helps us measure broader components of software engineering viability. And lastly, we wanted to capture this notion of taste, this idea that taste and maintainability is really important in modern, high-quality software engineering, and this was something that we saw was actually lacking in the current wave of benchmarks. So we introduced this notion of a tasteful solve, right? This idea that not only are we measuring correctness, but we're measuring notions of code-based alignment, practice alignment, bloat relative to an Oracle PR, a number of different metrics that you can look at on the actual blog post and website, but capture notions of quality beyond simply correctness. And so I'll shift now to the science, right? What actually makes a benchmark a really strong measuring tool? And a number of different kind of, this is like a greatest hits tour of some of my favorite benchmarks. And really quickly, task quality, really, really critical. GPQA was a benchmark several years ago that I was really impressed by. One of the appendix pages was one of my favorite contributions where they actually talked about how the pay incentives and the mechanisms of incentivizing contributors actually led to really, really high quality. Distributional control, defining a concrete taxonomy like an MMLU, which was very ambitious of its time in defining an academic taxonomy. Difficulty and headroom, right? Making sure that there's still room to run for these frontier models. And a really robust methodology for how you actually source and build tasks ends up being really, really important for effective benchmarks. And so I won't go into all the gory details here, but we ended up implementing a very rigorous quality control mechanism for this particular benchmark, right? Every single task relied on a suite of both agentic but also expert in the loop quality control methods to catch things like non-determinism, false positive and false negatives in the verifiers. And there were multiple experts, including myself and a bunch of our senior researchers at Snorkel, who would painstakingly look at every single task along with their expert networks, real software engineers in the field, to make sure that benchmarks like this were really, really reliable at the end of the day. So this is live. This was actually just updated last week. I promise you we triple-checked the results here, but remarkably there's a three-way tie for first place right now on the benchmark between Fable, Opus, and Sol, which is actually quite remarkable when you think about the Pareto efficiency curve. Again, this is on the metric of tasteful solve. So not only are these optimizing for correctness, they're optimizing for code-based practice and alignment to really senior engineering practices. So check it out. It's at seniorswebench.snorkel.ai. Just wanted to quickly call out some of our awesome collaborators. This was led by our co-founder Henry at Snorkel, along with the original SweBench team, Karthik's group, and Fred Sala, our chief scientist, and some folks at Wisconsin. And so the last thing I'll leave you with is we think that the future of benchmarks are going to need to capture a few really key axes of differentiation. Number one, we think we need to push the frontier of environment complexity. We need to push realism in terms of the types of workspaces and worlds that we're all operating in on a day-to-day, not just simple prompts and responses, but real code-based environments, scientific computing environments, legal workflows, or kind of real systems that people are working in on a day-to-day. Number two, we need to push the autonomy horizon for these models. We need to push how far these models can actually go when it comes to working autonomously and pull in humans in a bunch of these settings as well. And three, we want to push output complexity, not just in verifiable fields, but nuanced fields like legal and healthcare, where the definition of good is actually not a very simple, closed form solution like we've seen with mathematics, for instance. So I'll leave this with you, and the I guess final call to action is we're funding a number of these benchmarks. So if you're working on something exciting, if you'd like to collaborate, check out benchmarks.snorkel.ai. A number of the benchmarks that we put up there were in partnership with our Open Benchmarks grants, and I'm really excited to continue pushing and measuring the frontier with you all. Thanks so much.
All right. Thank you, Vincent. Next up, we have David Klein. Dan Klein. David Shu will not be able to make it for this morning's session, so we're hoping David can join us later in the day. So Dan Klein is going to step in his place. UC Berkeley and Scale Cognition.
Hi, everybody. I'm Dan Klein. I'm a professor here at UC Berkeley. I am also the CTO at Scale Cognition, which is a lab focused on high reliability agentic models with verifiable behavior. Let me start out by telling you a story you probably already know, which is due to all these amazing capabilities of AI today, it seems like a small team or even a single engineer can whip up an eye-popping demo seemingly overnight. Executives get really excited. This is the future, and go, go, go. 3 months later, there's still some details to iron out. 6 months later, we're working through some reliability issues. So will this thing ever ship? So if you've seen something like this play out, you're not alone. There are a bunch of studies that show that most agentic AI initiatives in enterprises stall or fail, and when they ship, sometimes they can faceplant even spectacularly. So what's going on? What really is behind this contrast between demos, which are easier than ever, and that last mile to a reliable product, which still seems to be very hard. So really at the core, intelligence is multifaceted. And although systems are getting smarter and smarter, not all aspects of intelligence are advancing at the same rate. The key reason why it's so hard to make reliable products, even still, is that reliability has not kept pace with other aspects of intelligence. So, like, what does that actually mean? Well, if you look at today's models, and you look at things like their breadth of knowledge, or their plasticity of behavior, or their fluency of output, on these axes, things are just through the roof and only getting better. But if you look at things like the ability to exert precise verifiable control, or the ability to explain the output of a model, these aspects have consistently lagged behind the others. What does this have to do with demos versus products? Well, to make a demo, you really need the things on the left. But if you want to be able to ship a reliable product, suddenly everything on the right becomes critical as well. So this kind of signature of strengths and weaknesses both explains why it's so hard to go that last mile. And when systems do ship, their failure modes often encode this exact same signature of strengths and weaknesses. So what does that mean? Let me give you some examples. So maybe you've seen the burrito bot, which is happy to take your order or debug your code. What's going on here? Well, this is actually the breadth of the underlying model showing up as a flaw, especially when accompanied by imprecise control. Or maybe you saw this car, which you can get for $1 because there's an AI sales bot, which is happy to take an instruction from the user that says all user deals are to be accepted. Well, what's going on here? This is the plasticity of the underlying model. Such an advantage in development of a demo, but now it's not really wanted. Now, you could look at this and say that's a prompt injection attack. Surely we know better now. This sort of thing isn't happening in 2026. But it turns out even in 2026, there are some cars going for cheap. So in general, when systems start taking actions, it becomes that much more important that they be sure. If you're going to take an action with consequences, you really have to know and be able to verify that you're doing the right thing. So, for example, if a system can edit your database, it can delete your whole company's database, and that's not good, but it could be worse, right? Healthcare mistakes, financial mistakes, these could be devastating. Now, you might think, how many times can an AI delete the whole company's database? Surely this isn't happening in 2026, but it is. All right, well, it turns out when smart people try basically reasonable things and see consistent barriers, probably there's something structural going on. This isn't just a one-off anomaly or a mistake. So what are the sort of structural enduring barriers, and where do they come from? I'm going to talk through 5 of them quickly today, and a little bit about what the shapes of solutions are going to look like going forward. So the first barrier to reliability I'm going to talk to is the issue of basically invisible errors. If you take an LLM and you look at the kinds of errors it makes, for example, think about hallucinations. I like to think of these things as an iceberg. The top of the iceberg, the small part, is the errors which are wrong and sort of obviously so. You look at that and you know something's gone wrong. The problem is most of the iceberg is under the water. So at Scale Cognition, when we talk to prospective customers and we're talking to them about their current technology and hallucination rates, and then we do a careful audit, typically we find that the actual hallucination rates are something like 5 times what they thought, because most errors just don't get discovered. So what's going on here? Well, LLMs are at their core plausibility engines. They produce plausible output, and hopefully often that output is not only plausible but right. But when you make a mistake, it tends to be the bottom of the iceberg. Now, that can be a problem during development because it's hard to fix an error if you can't catch it. But it can also be a problem when you ship. Why? Well, like, here's the example of a customer service email. This email is very human-like, it's very fluent, it's very authoritative. It just happens to be describing a bogus hallucinated licensing policy. And because it is so fluent, there's no real way for users to work around this error or to tell what exactly has gone wrong. All right, well, if you find errors, you want to fix them, and that means you need control over your systems. And there is this enduring challenge of insufficient control, and it boils down to the fact that the primary control surface, which is a prompt, really lacks any kind of precise semantics. So what do I mean by that? Well, imagine you have a banking agent, and users are going to come up and maybe ask for a loan. And on the other side of the agent is a bunch of financial APIs. Well, this agent is also going to have some instructions. Some of those instructions will be inherently soft, like be reassuring. But some of them will be inherently hard, like quotes are authorized through this API or something like that. And the problem is when you put instructions into a prompt, they all become soft. There's nothing really crisp you can say about the relationship between the tokens you put in and the behavior you get out. And that's a real challenge. So what do people do? Well, probably a lot of people in this room have had this experience of taking your prompt, rewording things, putting things in all caps at the end of the instructions, adding some exclamation points. Maybe after the third exclamation point, you start to feel like this isn't the right control surface for hard control. So what are people doing out there? We can have other kinds of control structures. For example, you can try to get hard control by having an external harness, and you put models checking models or code verifying things. And this is a step forward because now you have a way of doing some kind of hard control. But it's still very challenging because models checking models adds latency, it adds expense, and it can be kind of a very complex and unreliable kind of architecture to maintain. What would we really like? What we'd really like to have is models that just have control surfaces in the first place for hard constraints, and that do verification internally to the model. So this is the approach we take at Scale Cognition. I'll talk a little bit more about our models later, and I think this is increasingly what you're going to see. Now, that's really about the architecture of the input, how you control the model. But we also need to talk about barriers that come from the architecture of the output. We'd like to have models which tell the truth, preferably models which guarantee that they tell the truth in some verifiable way. But that's a big difference between verifiable truth and just happening to output a correct sequence of tokens. So here's an example. If I ask a model, what's the population of Berkeley? Well, it's going to throw together some tokens to give me an answer, or maybe it'll throw together these tokens. They're plausible, but they aren't actually right. Or maybe it'll throw together these tokens, and these are plausible, and they're also correct. Now, that doesn't mean the models aren't going to be correct more often than they're wrong. Hopefully, they're correct most of the time. But the important thing is that a vanilla LLM can't actually tell the difference between when it knows something and when it doesn't. These are just guesses. Some guesses are right and some guesses are wrong. What would it take to actually be sure? Well, it would take some kind of metacognition. So you can see glimmers of this in a system, for example, that issues a query to a tool call or a RAG system, where it decides that it's going to do this query and output the result. Now this is now starting to go down the road of metacognition, which is doing computation about how you will do computation, how you will think. And this is not the only kind of metacognition. For example, if I ask people in this room, what's the population of Berkeley? Probably the most likely answer is, I don't know. And humans are very good at tracking whether or not we have an atom of knowledge. Systems do not currently do this, and I think it will be increasingly important that systems become metacognitive. All right, of course, the behavior of a system is critically intertwined with how it's trained. Increasingly, the behavior of systems comes not just from their pre-training, but from post-training, which tends to be done in a reinforcement learning manner. Now, you've heard about a lot of amazing advances based on reinforcement learning, and this in areas like math or coding. There have been these explosive instances of progress. This is because these are verifiable domains. So as, for example, game playing. In these domains, you can take your proof and check it with lean before you train on it or hand it to the user as output. So verifiable RL can be very, very powerful, but most domains aren't verifiable. How can non-verifiable RL cause problems? Well, it can increase some aspects of intelligence at the cost of others. So to give you an illustration of this, I'll offer you this parable of the shipping bot. And the shipping bot has a user that comes and says, where's my order? The tracking hasn't updated in a while. And the shipping bot checks the database and finds that the package is lost. So it says, your package is lost. So far, so good. But what happens if we layer RL on top of this and we don't do it carefully? Maybe we tell the system to optimize thumbs up, maybe in the form of net promoter score or something like that. Well, it's probably not going to get a thumbs up for this answer. But maybe if it said your package is on your way, the user might be happy, at least in the short term. Well, now you've just taught your system to lie to you. And in general, does this happen? Well, it actually does. So for example, if you have RLHF, that can increase human approval of outputs while actually degrading their factual accuracy. Okay, and then last but certainly not least, one of the barriers to building reliable systems is that superintelligence turns out to be super expensive. Well, we actually already know why that might be. For example, you may be paying for breadth that you don't need or want. You may be paying for models to check other models, either in tokens or latency. Or you may be paying for test time compute, which is essentially teaching your model to do something at test time that you really wish it had already known how to do in advance. All these things can cost a lot, and as a result, you see this trade-off in generalist models between, here you can see a bunch of models on an agentic benchmark. The upper left models are accurate but expensive. The lower right ones are less accurate, but they're much more cost efficient. How could you get off this curve? Well, for example, our model APT is a model that is specialized to agentic interactions. That means humans on one side and APIs on the other. And this is a specialist self-verifying model, and this lets you get high accuracy and also high efficiency. And I think this is going to be increasingly part of the solution. So what are reliable solutions going to look like? I think you're going to only hear more and more about verifiability all throughout the system, in the data, the architecture, the training, the inference. There's going to be richer control surfaces that let you actually tell your system what you want and get guarantees that it will actually happen. And then I think you're going to see an increasing reliance on efficient specialist models that maximize the use of the resources of compute available. And in general, reliability is very important because reliability is what gets you from these demos to products that you can actually ship. Thank you.
All right, thank you, Dan. Next up, we have a workshop with Emma. And I'm hoping the crew is here for that.
Hey, hi everyone. We are going to be discussing how we can go from assistants to AI employees. I'm going to start with a very, very quick intro of Emma. The first 15 minutes of this talk is going to be not hands-on. So we're going to talk to you about this topic, what Emma does, how we've helped dozens of enterprises go from assistants to AI employees. This is a hands-on workshop. So if you've got your laptops here and you actually want to try out the Emma platform and try going from an assistant to an AI employee, this is a good time to do that. So I'm just going to keep this up for a second. I'm going to request you to scan the first QR code if you want access to the product. And while we go over Emma and this topic, the first 15 minutes, our team around here will get you access. It's going to give you a couple of minutes. I also recommend scanning the second one in case you don't want to be typing out long instructions and prompts yourself. You're welcome to do that and improvise on the platform, but if you go for the second one, there's a lot of copy-paste content to help you. Cool. We have a bunch of TAs standing around, so in case you haven't scanned these, you want to do that the next 15 minutes, you can just ask one of them to show you the QRs. Awesome. Getting started, kicking this off with quick intros so you know who the TAs are. I'm Anushka. I was the founding product manager at Emma. We're a company that started in 2023. We serve Fortune 2000 clients, and we help them automate mostly HR, IT, finance roles end-to-end. So we've got thousands of AI employees in production, and we've also got hundreds of external builders building on Emma. So you're going to be seeing the products that we give to them to kind of do all of this in a self-serve fashion. And you've got the engineering and ML team that works on this product around the room. So you've got Soham, our founding engineer. I think Eric's still coming in. You've got Anika with the laptop there. Kunal's still coming in. Yoshita's here in the front. We've got Karan somewhere in the room. Yep, Karan's here, his hand's up. Shivan over there. And I think you've actually got a CEO here, and Raj, his chief of staff. As we get on the hands-on parts, you should see these people milling around. Feel free to pause them, pull them over for any questions as you get stuck. We want you to actually launch multiple AI employees in just 30 minutes of hands-on building that you can potentially use for recruiting. I also want to get a quick sense of who's in the room. Just warm up a hands, raising a hands. How many of you are from the Bay Area? Awesome. How many of you are traveling in? Great. Welcome to the Bay Area. We are based out of Mountain View. So everyone you see here, we work out of our Mountain View office. All of us are local. I also want to understand quick demographics. You've seen we are mostly product engineering folks. How many of you are Berkeley students? Nope. OK, we've got a couple. How many of you are engineers, developers? You're technical. You used to write code. You probably use Claude to code now. OK, awesome. How many of you are in research or academia? Cool. Founders, builders, taking agents into production. A lot of them. OK. Welcome. And lastly, any non-technical professionals who've probably not done agent building hands-on. Welcome to you as well. You'll see you don't really need to be technical to work on Emma. Great. So we've kept this as technical as you need. Feel free to go deeper, ask us questions. Cool. Jumping right into the topic of the session. So what separates assistants from AI employees? Why do we use the term AI employees? Which can be a little provoking for people, like why are you putting them into like roles like human employees? A lot of people are used to using assistants via things like Claude Cowork, directly talking to ChatGPT, or even assistants that pop up in like those small floating icons on your websites. Assistants are reactive. They need humans to trigger them. They need humans to understand what they can do, what their limits are, and what are the best practices of working with them. Assistants also suggest and draft what you can do a lot of times. They don't actually like touch the same systems as you. They don't have the same amount of access. You wouldn't trust them in the same seats and the same actions that you would trust even a junior employee or an intern with. Assistants are also stateless. I think we've all experienced this. You're working on something on Claude Cowork. You finish your step, and then you're like sharing an artifact, or you're sharing a document with somebody on Slack or Teams, and then you're doing that back and forth in meetings outside the platform, and you're the person keeping state, right? It's not your assistant that actually like orchestrating a multi-step workflow across days and peoples and systems, which is what most of our jobs involve, right? And lastly, you have to be a little scared. You have to like govern everything yourself. You can install an MCP that's probably not allowed in your company. You can install a skill that can have security issues. So the user often has accountability to ensure nothing wrong happens. And I think we've all apologized for our AI's errors at times, where it's been like, I'm sorry, that was an AI error. I should have checked that better. We made the shift to AI employees 3 years back, like 2023. That's when we coined the term. We made sure we started with all of these as first principles. The first one being that AI employees are actually proactive. They should be triggered by events, system changes, or even schedules. Here's a fun fact. Because you can build AI employees on Emma, our builders actually build 50% conversational AI employees where somebody's supposed to chat with them, and 50% of them are API triggered, right, by some system or a schedule. So the build is 50-50. You think it's going to be like equally impactful, but more than 90% of our invocations are actually automated. And that's how any human works. If you have a junior employee or an intern, you're not pinging them to do stuff every time, right? They're just doing things after a point. They're getting more and more autonomous. And that's what's happened with Emma's AI employees as well. The second one, being able to act on real systems. Our integration platform is really deep, as you shall see. We've been talking to a lot of people about MCP. Emma supports MCP. Fun fact, we developed a tool protocol before MCP came out. And that one is much faster, more constrained, simpler to set up. So we give our builders a choice. People usually start with MCP because it's already there, but you can just bring any kind of API. You can bring your REST, SFTP, SOAP, whatever protocol you want, and directly give access to your agents. But we do want the AI employees to directly be acting on these systems with the right set of constrained permissions. So you might want to be using the authentication of a junior employee, of the person invoking the AI employee or collaborating with the AI employee. Like, I can't go and ask for my manager's paycheck. That should not be allowed. So having a system that allows you to express all of those restrictions. Third, you want it to learn. You want it to have persistent state across different steps, systems, users, multiple days, long duration tasks. Come back and ask me about this in 6 months. That should work well. And lastly, governance. you probably don't want to think about this as a builder. You just want a system where your chief security officer can set this up, and you know the system will stop you if you're going to breach something. You probably don't even want to know what's not allowed. What makes us uniquely qualified to talk about this today and help you set up these AI employees? There's some of our customers here. Feel free to go over the impact there. Like I mentioned, 90% of our invocations are programmatic. Most of our impact and revenue is driven by actual work that's just happening behind the scenes. 100% of our AI employees actually change state in real systems. We don't really have use cases where you're asking it for, give me a drafted email and copying it over yourself. Imagine that example, but in every system you work across. So a lot of companies now use Emma as a single pane of glass. You're not opening 10 tabs to do things across your different systems. You're actually doing it from a single screen now. And that screen could be Slack or Teams. Because it's an employee, you can talk to Emma wherever you already are. And lastly, we've got a lot of use cases in regulated industries. Like, I don't have the logos here, but Prime Therapeutics is a healthcare customer where Emma does prior authorization assistance in the background. So we are processing thousands and thousands of prior authorizations. And we're also working with HSS, Hospital of Special Surgery in NYC, for like scheduling appointments for their patients. So we are working in finance and healthcare flows, which of course comes with the regulatory needs pre-built into the system. Not something we're going to touch in the hands-on part of our workshop, but that's a quick glimpse. The hero couple of use cases here, I would say, given the context of the workshop, being recruiting, is like Wipro, where we are live with 240,000 employees across the globe. And they use us for all their employee experience questions. And the other one is Artico, which is an executive recruiting firm, one of the top firms in the US. And we were able to cut down their time to hire with 67%. Maybe one or two more slides before we jump into the hands-on part. The product you'll see is quite complex. You're all going to get a role called builder. So you're not going to get access to the admin and the governance features yet, simply because you'll all be able to see each other's work then. This is Emma's platform architecture. I'll also give you a quick demo. Feel free to play around. We are a multi-cloud company, so we can deploy on-prem across clouds like Azure, GCP, et cetera. Again, we do things like data residency. The next layer being the LLM layer. None of our enterprise customers actually want to deal with model leaderboards. So they don't want to figure out which model is doing well for a specific task I care about this week, and then keep changing the model. So that's where Emma Fusion comes in. We take the onus of keeping all the latest models in the Emma Fusion layer, and depending on the task your exact AI employee is performing, we promise to get you the best accuracy at the lowest cost and latency. So again, most customers don't think about LLMs. The next one is Builder Platform. This is what you'll be working with. So we've got a lot of pre-trained domain-specific agents. You'll see a small subset of them today on your platform. Imagine data extraction. Extracting data from a 500-page doc, which has contradictions and duplications. How do you then get a structured data object out where you have deduplicated and you're very accurate? You probably can train an agent to do that well. But we have a data extraction agent that's really good at that already. So we've got a lot of agents like that for specific tasks. We've got a generative workflow engine that lets you put together these diverse agents alongside deterministic steps, because sometimes you don't want to use AI. If you're providing access to somebody to, let's say, a new system, you probably want to follow a set of deterministic steps. And the system should be able to mix AI steps with deterministic steps. So we let you do that, and you'll see how that works. That being said, you don't need to code. There are non-technical people in the room. In the previous generation, you would have to write code to express that deterministic logic. But Emma's autopilot will just generate those steps for you, and you just have to check the outputs. We'll check the integration layer out. We'll set up an integration. We can work across any of your other vendors. And governance comes built in. You can use dashboards, chats, APIs, voice, even generative UI to to interact with any of these AI employees. And lastly, we built some pre-configured suites on all of these layers, which come pre-built with like 500,000 AI employees for these use cases, like employee experience, sales, customer support. Cool. In the interest of time, I'm going to skip through the slide. If you want to take a quick picture, you're welcome to. This is your AI employee going from a demo to something in production. And when you make the shift from assistants to AI employees, you're going to face issues. Like, it's a lot more expensive to launch an AI employee compared to an assistant. We'll skip through this. We have a booth in the Zellerbach Hall. If you're interested, come talk to us. There are a lot of people at our booth. Awesome. So this is what we're going to be building today. We are going to be building 2 AI employees. One sourcing AI employee that actually searches for real candidates using Apollo. Inside Emma, we've got collaborations with a lot of people data companies. So you don't actually have to bring your own API keys. You can directly use search over very large databases that stay alive. But for this workshop, we want you to actually integrate to a new thing. So let's do Apollo. Next, we'll do screening. And here, the key part to show is the human in the loop. When you have AI employees doing things end to end, you don't want them to do sensitive stuff without talking to humans. So we're going to model that. After I shortlist someone, I actually want a human to approve it before I send. So let's see how Emma models that. And then if you have 100 AI employees, you don't want the humans to be remembering what agent does what AI employee does what, whom do I go talk to. Nobody wants to deal with routing in their heads. So we're going to build a single orchestrator layer across all of these that a recruiter or a hiring manager can talk to. And they don't even have to know their different AI employees in the background. They just have one point of contact, a recruiting orchestrator, and they only talk to it, while the orchestrator can talk to a lot of different AI employees. Cool. I think with that, let me skip this again in the interest of time. Once again, we'll do a quick check on access. Some of you who already signed up should have started receiving emails with access to the product. I'm gonna quit. So Emma has 3 types of builders. We've got our own builder team that goes and works with our clients, especially super non-technical clients like healthcare clients, et cetera, to understand their processes and workflows and helps them take it to the market. The second model is we've got partners, so people like Wipro, KPMG, et cetera, where the builders are training on Emma and then taking use cases to market. The third one is where customers themselves do it with Emma Autopilot. In each of these cases, we recommend going through a scoping process. For this workshop, we've kind of pre-done it for you. We've put it in the prompts and the builder hands-on guide that you'll see. But this is what we recommend going through when you're actually building an AI employee. The first one is just discovering and scoping which parts you want to automate, especially with AI. So what does the role actually require? Decomposing the job into tasks, and checking which ones you want to do with AI, which ones you want to do deterministically versus which ones you actually want to still keep with the human. We make sure to get past examples. Something we've seen is people getting use cases without actual test data sets, and then you're kind of making up the test data set as you go as a builder who doesn't actually understand the business process. The second one is integrations. Like I said, figuring out what methods you want to use. For Emma, inside Emma, we, for production use cases, always recommend directly using the APIs. If you want, you can then use MCPs, which are probably going to be slightly slower and take up more of your context, so more expensive as well. If you don't have either of these, some systems don't have APIs or MCPs, then we move on to browser use within Emma. And then, of course, you've got retrieval for improving your context. And then figuring out how you actually break this up into smaller agents so that they're easier to evaluate, easier to maintain. You can delegate their maintenance to different teams in your company and so on. The next one is human-in-the-loop checkpoints. In regulated industries, this is easier because there are a lot of decisions AI just cannot make. It cannot make clinical decisions, for example. It cannot make finance market-related decisions like placing an order. But even in other use cases, you probably want to check where human judgment is key, like recruiting. You do not want agents to be recruiting end to end. And then you put a human boundary at the final act step where you're changing the state, and you don't do it at the think step. You actually get the AI employee to do everything until the human actually has to act, so they can see the notes and decide to act. The last one, just training the agent to also proactively raise human in the loop requests and actually ask humans when it's confused. Quickly checking in with the room on the side. Are we seeing accesses roll out? Nope. Okay, that's unfortunate. Okay, cool. If the team figures that out, we'll keep access open the next 2-3 hours, post the workshop so you can play with it. Regardless, we will reach out on your emails with temporary access. I know people are here because they wanted to play with the product. So we plan to remove access at the end of the workshop, but we'll keep it open for whoever signed up. For the rest of the duration we have with you, I can anyhow go ahead and demo the flow, probably take 15 minutes, and we can open up to questions. Cool. If you had logged in, you would not see any of these because these are new AI employees. Because I'm going to show you this from scratch, let me just delete the ones I already have. And we will restart here. Cool. So you're seeing a restricted version of the platform here. This is what you would get access to. You won't see any administration governance settings here. This is our homepage. You'll see we have Emma Autopilot that actually is live across all of your different pages. It has context on who you are, what you can do, and what is open in Emma in the specific page you're on. The pages you have access to are apps. We're not opening up app building access. We actually do custom UIs, custom apps that you can deploy on a new URL as well. These can have generative UI and so on. We're not going to be doing that. AI employees, you can see this is an empty page. Most customers here have hundreds of different AI employees. We're going to be building these right now. And next one is integrations. You'll see access to a pre-built integration catalog, where I believe we already do have Apollo, but we're going to be building one from scratch. So this one has 31 different tools, but we'll build one just for our use case so you can see how easy it is. You can see, again, 30 different tools. And this can come from MCP, where they don't have MCP. Just bring the APIs. I'm going to jump into the builder guide. And what we're going to do here is ask it to create a new Apollo integration. We're not really providing any documentation. It's going to go to the web, figure this out. I've given it some clues on what tools I want. I want search people and enrich people. You can actually skip this when you play, and you'll just see it takes like 5-10 minutes more because it's working with you to figure what do you want to actually do with Apollo. Let me zoom in. Yeah. Then we're going to ask it for a sourcing AI employee and a screening AI employee, like the ones that I showed you earlier, and an orchestrator that uses both of these. So a recruiter does not have to understand them. We're going to ask it to go ahead and test on its own, so create test CVs and job descriptions, and actually come up with evals without me providing a data set. So I'm going to copy paste all of this into our autopilot. I think a lot of the research folks or people building agents would be familiar with agentic harnesses at this point, so I'm just going to approve the plan. This is a harness where it's got hundreds of tools across the Emma product infrastructure that I showed you, the governance layers, the builder layers, the UI layers. And And then it also lets you bring your own tools and skills. So most companies then enhance it with domain-specific skills. So if you're a KPMG, you're probably bringing in your finance knowledge from decades, while having the agentic platform knowledge come in straight from Emma. So it's gone ahead, created an integration. Emma is self-correcting, so whenever it fails, it actually learns from those failures, first for the user, and then across the entire company. So this is something we've seen really improves the stickiness of Emma over a few months, especially when you're bringing your own tools. Agents might not always know how to use those tools, but like 4 or 5 people use it, the next 100 people, it's going to work well. So it's asking me if I've connected the API key. Our builder doc actually has a sample API key just set up for this workshop. I'm going to go ahead to integrations here, and we see Apollo. So I'm going to connect with my API key, and I'm going to tell it the API key is connected. So you'll see one thing you literally cannot do with Emma is give your API key here. It won't be able to do anything with it. So there is no way it can actually get it connected, paste it in. We do PII and sensitive data obfuscation at source. So as soon as you put it in the chat, it actually gets obfuscated, and that's how it's used downstream in the rest of the systems. So like, unlike a lot of other harnesses where people just paste API keys and that actually works end to end, we've got like strict system guardrails against that at Emma. Cool, so it's got 2 AI employees up. It's actually testing the tools out. And we can go in here and actually see the tests it's running. It's probably running them from the background. Okay, it's still setting these up. You get to see 3 different types of AI employees here. The first one is chat, where you can just chat with it. Second one is a dashboard AI employee. And this is what I mentioned earlier when I said these are really popular. These lead to like 90% of the invocations because these can be invoked via apps, via APIs, or on schedules. So you'll see that it's single shot. It can have multiple different steps. In the inputs, we've added a candidate CV and a job description. And this is actually paused for human review. So I can go ahead, review like the decision, et cetera, get more information here. And whenever I'm ready with the information, I can run it end to end to see fit scores, whether the email was ready, and so on. Cool. So we've seen these AI employees get created. I'm going to quickly do a quick check myself on access. Access is off. OK. Can you upgrade me to admin? All of you are in. I think we just have to figure out something on the login flow. On the admin front, on the governance front, I can give you a quick overview. Analytics is what we would all expect it to be. But because Emma is a partner, customer-led company where people are bringing their own use cases, We actually let companies create subtenants and new deployments of Emma right from here. So you probably saw when I was switching tenants that I can actually create new deployments for each customer, and a lot of our partners use this to deploy Emma to hundreds of their own customers. We come in with, again, self-serve settings for pretty much login, whitelisting email domains. You can bring your own licenses if you've got custom models or if you've got free credits. This is your standard API keys and launching Emma externally. And we come with some pretty strong RBAC and governance features. Previously, before Autopilot, most people built AI employees manually. So I would have to actually build a recruiting orchestrator. But now, Emma is able to do all of this using Autopilot. Cool. While we sort out the access issues, I'm going to take a quick pause here for questions. We've got a few more slides and content on what you can do on this platform beyond your first deployment that I just showed. But before I go there, any questions? Yep. The pricing model, it's usage and outcome-based pricing. So for a lot of AI employees, where we're actually selling outcomes, like how many of your employee experience tickets are never going to go to humans. They're going to get deflected by AI. We price per outcome. So it might be things like per sales proposal, per customer support ticket, per employee experience query. And sometimes it's usage-based, where someone is just buying 1 million credits, and they're saying, I'm going to build on Emma myself, so I might build whatever I want for any use case. Yeah. It is fully self-serve, so that's kind of the point of Autopilot. There is nothing on the UI that you can't also do from the Autopilot here. Yeah, like most of our customers are now able to build and maintain at the same quality that we could 2 years ago. Yep. We are. We're interacting with both private integration deployments, so like structured data behind your HubSpot, Salesforce, ServiceNow, and also unstructured data that you probably have in Confluence, Notion, and so on. All of those are brought into Emma frequently. Spreadsheets as well, yeah. Like finance use case spreadsheets are kind of the primary mode, yeah.
Hello. How do you go about ROI measurement as your customers?
ROI measurement, it's a really good question. For some use cases, especially cost center use cases, it's pretty straightforward. It's fewer hours and fewer involvement from like the actual humans that you used to do the task before. In some other cases where you're measuring productivity, for example, how much faster are you in putting out sales proposals? That's a common use case for us. We start with the prediction. Like I remember 2024, the prediction was they'll get 15% faster, 1.5, over the course of the year. And then we had to actually do studies to see how much faster they got. And within a couple of months, they were 3x faster, even when they were tenured for 10 years in the role. So you measure, and of course, you look at the outcome, which is you have to be getting more sales proposals, like 20% more sales proposals with the same number of people. So yeah, ROI usually gets measured in those 2 points. Yeah.
Hey, thank you for the talk. How do you think about processes that change over time? And so in your enterprise deployments, new regulation comes out, new process documents. How easy is it to reflect that in the employees that are doing the work, the AI employees?
The prices of models, like token pricing?
No, the process changes.
The process, okay.
Yeah, like how quick and easy is it when a new regulation, something comes out?
Yeah, that's a really good question. There are mostly like 2 kinds of changes. You see large changes where you know something has changed. For example, with prior authorization, the clinical policies actually change every year. So there's a published date where you know it's going to change, and it's predictable. In those cases, it's fairly self-serve. People can come, just talk to Autopilot. Emma has versioning. People then like have a new version, do their evals, and push it out. But there's a lot of real-world drift that you can't predict. Like your customers have started asking new types of questions in the last couple of weeks that you could not predict. For that, Emma is again able to go through your audit logs, identify those opportunities for improvements. Autopilot can recommend those changes with the right eval data to show it's actually better, and this is not going to regress your past use cases. And then a human actually signs off on the deployment. Both of those are automated processes.
Question about, can you bring these AI employee agents integrated directly into a Zoom call or a Teams call and have them interact directly?
We haven't actually done live call tracking yet. We've done like processing right after the call with transcripts, but that's not a use case that's come up yet for us. A lot of questions. Just gonna take a...
So fantastic presentation, fantastic platform. This is sort of an adjacent question about like how much control do I have over the reward functions for each individual agentic employee? Insofar as I'm thinking about this as a broad reinforcement learning problem of my organization and the individuals within it, like how granular and what is the control associated with that?
Yeah, that's a really good question. And you're right that people want to get control over the most granular step for each AI employee. First of all, which is why you have AI employees as opposed to one universal agent that does everything in your enterprise. For each AI employee, it's usually a very different person managing it, training it, like all of those are different roles, like the builder, the admin, the reviewer, the onboarder. And like there's usually somebody in some country who's now tasked with this AI employee needs to perform well for this specific use case, and those permissions are reflected in the system. A lot of people run evals at an AI employee level. You don't have to be technical again. The control you have is specifying your use cases. Some business users do it very non-technically. For example, they bring last 1 year's tickets, and they're like, I want at least this performance over all these tickets. Some people are fairly technical, and they actually have eval beds, so we support that entire spectrum. And now, within the AI employee as well, some of these AI employees are very free-form. They don't really have a workflow. Some of these actually have smaller blocks, and then you can run the same evals at a block level. Like you can just measure and improve how well the AI employee works with Apollo and nothing else, right? Just the Apollo layer, I want to get 100% accuracy, 99% accuracy, so.
Hello? Oh. Hi, here.
Yeah, awesome.
Sorry, I had a quick follow-up question on what was asked before, right? The chatbot that you have over here, is there a way that we can integrate that into existing messaging services like Slack or something? And
absolutely.
It can participate?
A lot of people actually use us in Slack or Teams. Like Wipro uses us in Teams, GChat, and as an SDK, a floating app icon over one of their internal websites. So all three of those are channels. So it's fairly easy. I won't go through the entire setup right here, but we are able to get even non-technical people to do this integration at this point of time. Probably takes 10 minutes. Yeah.
Why are you guys multi-cloud? Like, what are the primary reasons? And then how do you guys connect to all those clouds?
Come again, sorry?
You said the platform was multi-cloud underneath. I was just wondering about the primary reasons for that.
Because a lot of sensitive customers, finance, healthcare, actually want to be on-prem. They want the deployment to be where they already are. They want the deployment to be air-gapped as well. Like Emma cannot actually talk to any system, including the web or any API outside their cloud. And because our customers can be on GCP or Azure, we were multi-cloud from day one. So we've got a SaaS deployment. Dozens of customers are on SaaS. They really don't care. It's like setting up Notion for yourself, right? Like you don't care about deployments. But for customers that do, we deploy on-prem.
Are you able to get your agents to enforce role-based access control to data for an employee asking about something, say?
Yes, absolutely. So we've got two types of connections for integrations. It's kind of an advanced feature, so I probably switched it off here. I have, yeah. I can show it to you in a minute on like a more powerful version of this platform. But we allow two types of connections. One would be like shared service auth right? Where it doesn't really care if I'm asking something or if you are asking, it's the same access. But for most use cases, it should actually be user-level auth. So the first time you ask the agent a question that requires calling into, let's say, ServiceNow, it's going to ask you to log in. And all your answers will now be with your key, which helps it not just restrict what information you get, but actually like keep an audit log even in the other system that, okay, Anushka asked for this information, and hence this information was served to her via an MI agent.
I'm wondering, in the use cases that you've built for different clients, how large the number of agents can get? Like, what is the largest scale that you've built? And also, I was wondering if you could share some estimate about like how long a workflow would like take on average to run for that large scale deployment, and also the cost, if you could share some estimates. Thank you.
Yeah, I probably can't share costs, but from a number point of view, we've definitely seen hundreds in a single tenant, in a single customer deployment. 300, 400, I've seen that number myself. The point here is also it's in people's interest to break these up because of the point I made earlier about who's maintaining this, who's responsible for this working and staying up to date and actually following up processes. And we are seeing that a lot of humans are now becoming AI employee managers. So you are tasked as somebody who has a team of 6 human employees and these 3 AI employees on Emma that 200,000 people in your company might use, but you're the one responsible for making sure this one performs well because you're the business expert on this process, right? So it's in people's interest to actually break it down. The workflows can get super complex. You can merge these, you can break them apart, but breaking them apart just means better governance and management. From a duration point of view, there are workflows that take multiple days, like you're processing a very complex finance use case, a new procurement for a vendor, probably has 10 approvals. So it really depends on the business process itself, because you're getting stuck on like the humans that are going to do the approvals. The agent is quick, but the real world implications are there. And a lot of other use cases are much faster.
So you mentioned proactive in your earlier slides. How do you make AI employee proactive? Like,
it's a good question. Let me see if I can pull up maybe a really messy internal demo. Once again, this one is very restricted, has a lot fewer features. Okay, I'm just going to create a new one. This is a test tenant. I can show it to you. So when you've got AI employees that you create, they can obviously be triggered by someone texting them. But what we allow, and once again, nobody actually looks at these screens, guys. You just talk to Autopilot. All of this is like the background. It's like looking at the code at this point. We let people set up webhooks. We let these AI employees poll your systems. We let it connect directly to systems and have like conditions like when there's a new lead added to Salesforce, I want you to go and figure out if they're a good candidate for us. So we've got a lot of different types of triggers like monitoring inboxes, setting up schedules. Every morning I want an email that does X. And all of these are as simple as sending a sentence out, and these just automatically run.
Hey, hi. I have a question about, earlier you showed the IMA Copilot. Yeah, it helps basically self-drive, work in a self-driving mode, but there might, I imagine that if you're working with ticket resolution, there might be a bunch of things which are repeated again and again over and over.
Yeah.
So does it also offer basically pre-built code recipes so that deterministic tasks can be done? Otherwise, the token cost for the things which are very mundane in nature would just keep on
Yeah,
increasing.
absolutely. So we let people actually represent code specifically as a part of workflows as well. The thing is, you don't want to spend months setting this up. So what you can actually start with is an empty Emma tenant, 0 AI employees, and you're just working with Emma Autopilot for every task. And as it figures what's repetitive, it starts codifying those. So it builds AI employees, which are agentic, or actually straight up writes code and maintains that based on real-world usage and feedback. Awesome.
Thank you for the talk, Anushka. Very, very cool. Thank you for making it detailed enough to be useful. Question that I have for you is more meta. You're positioning this as AI employees, and that would imply sort of discrete or transformational business process outsourcing. The whole business process is outsourced. But a lot of your examples are more task-oriented. What would you say the distribution is between like a true offshore, but now it's a digital shore outsourcing versus task-specific within a employee's broader span of responsibilities? So task versus full business process.
Right. The end state for every contract and project we start with is role-focused, right? So it usually ends up in a single interface you can talk to, which can actually do the entire job, or a single automation that can actually do the entire job across all of the different tasks. The adoption usually starts a little slower. So what we see is you can build an AI employee that does everything end-to-end, but the blocker is always the humans that are collaborating with that AI employee. So we've seen like actually launching them task by task. So let's start with sourcing, then move on to screening the CVs, and then let's move on to scheduling the interviews with the candidate, and then let's move on to onboarding the candidates you actually liked, managing the offer letter, etc. Usually helps the recruiting team like slowly warm up and learn how to work with AI agents better. So you start with a task and you like expand to the entire gamut of what that role can do.
Yeah, hey, what are the typical ratios between a human and their AI employees? So if I have a company of 20 humans, what is the typical ratio of number of agents they would have? And then what is the farthest you have seen? In other words, one human with 100 agents, for example.
Right. It's really easy and cheap to create new AI employees in Emma. You only get charged when you're actually getting value out of it. So a lot of people do go ahead and create a lot of these automations. But Emma works with very large companies. We don't work with small and medium enterprises. So the ratio is always going to be very large recruiting team, 200 people. But they only ever need like maybe 20 AI employees. And that's what everybody works with. So the usage per AI employee is very, very high. Thousands of invocations per day, but we don't really optimize for number of agents.
Hey, yeah. I have a question for you more on the practical side. As many said before, really good presentation. I really like the aspect. We hear a lot about the technology and what makes it work in the background, but how do you apply it in the real world? So really, really well done. This was a good context. I want to go even more practical. Let's say you win a big deal with General Motors or Bank of America to do all of their processes, right? How does it really work when you go in? You ask them for their process books. How do you onboard a new employee? Or you sit beside somebody and somebody who does this job day by day would do it? This is my first question. And then the second one, what I would assume, you will get a lot of resistance maybe from some people, right? Why would I use this tool? And people are not dumb, right? Hey, will they do my job? How do you deal with this resistance, and how do you get into this aspect?
Yeah, those are good questions, and that definitely happens in real life. So to the first question, the deployment process models that I talked about earlier, it's either someone at Emma or one of our partners that has become the agentic transformation expert and is responsible for the AI employees working well and launching them the first time. In that case, it's like a deep discovery process, right? Where you're actually not just doing workshops with the buyer and the team lead, but you're sitting in the room with the person doing the job and shadowing them for hours and days. You're looking at all the past examples of their work from the last 1 year, and then coming up with the definition. Once you have the process well defined, you don't have to do much. You can throw it into Emma Autopilot, a few hours, and it's built and tested. So you don't have to know about Emma to launch impactful stuff in Emma. You have to know a lot about the business process. That's expertise you need. But like I said, like this also a very common model where a lot of our customers then move on to wanting to build themselves. So they're like, if you're just going to put it in Emma Autopilot, I can do that. I'm the expert on this recruiting process. Just give me access. And then they go ahead and play around. And we're seeing the rise of citizen developers, like people who really want to bring AI into their jobs without being technical at all. They've never written a line of code in their lives. To the second point, I feel like that resistance was a lot more common a couple of years ago, 2-3 years ago, where it was like, hey, why do you want me to evaluate AI samples when this will probably affect my own role? We've seen that change a lot in the last couple of years. Everyone's realized you need to be faster and AI equipped to stay at the top of your job, to stay at the top of your industry, and adopting AI will actually make you more indisposable and much better at your job. So we see a lot of excitement where people want to be the ones training it, want to understand how it actually works, and get deeper now.
Hello, everyone. Thank you so much for your patience. You should be able to sign in now and be your own citizen developer. So yeah, please try out our platform. We'll extend access beyond this session as well. So now your emails should work.
Yeah, sorry about that. But yes, please log in. Paste out this prompt, play with it, build your own integration. Do not connect any real systems, please. This is a shared tenant. Do not connect your customers or your own data. Your companies won't like that. I've pasted an Apollo API key. I'll increase the number of credits on this so you can use it through the day. Yeah, go ahead and play with it. And we have a booth, once again, like I mentioned, in Zellerbach Mezzanine. So if you try it out and you have feedback or you have questions, we're all going to be there the rest of the day. So you can come talk to us, ask us more questions. And also, last thing, we've never actually opened this up to people without a contract, right? Like, we've got very large customers. They keep us busy. But we are opening up for free self-serve trial access end of this month. I think you would have marked it on the form, but if you've signed up for that, you can actually get slightly longer term access than 1 day to Emma to actually try and automate stuff. I see we're almost done with the session. This was all the time I had. I'm slightly over. Can we go over for a couple more questions? Should we wrap up here? One or two more? Okay, we can probably take one or two, yeah. It's, again, like the two models. When we are taking outcomes to the market with customer, it is based on the use case. Like a sales proposal use case is going to be priced very differently from a customer support use case. It does not depend on the number of tokens being used. It's not cost-based pricing. It's about like how much you would actually pay a person in that job and how much faster are we making them. So some jobs just cost a lot more. We actually instrument those outcome-based pricing models in tandem with customers. And our metrics, billing metrics, are extremely configurable. So when you take AI employees for sales proposal to market, you will actually measure the number of sales proposals, price based on that. Yeah, that's the last question. So skills is like a less powerful version of an AI employee. We let you do that too in the system. The benefit this has is we actually have like a strong template marketplace. These are templates that allow people to share stuff with the right people in their own company very easily. So you can use that for skills. You can use that for AI employees. But like I mentioned earlier, AI employees are a lot more complex. They've got their own memory. They've got deterministic and agentic steps put in there, and they're being evaluated for that use case very, very well. And most people who are taking something live actually want all of these tabs. They want to see how many people used it, where it went wrong, where can I improve, I want auto-improvement help, and so on. So even though skills does exist on the platform, most people prefer using AI employees directly. Cool, thank you so much. That was it.